In this video, we are going to discuss about continuous probability distribution. For a continuous random variable x, the function f of x satisfying the following conditions will be known as probability density function. So, what are the conditions we will see? If it is a discrete random variable, the function is known as probability mass function. If it is a continuous random variable, the function is known as probability distribution function, probability density function, which is mentioned as PDF. So, we will see the conditions now. First condition, integral of f of x between limits minus infinity and infinity should be equal to 1. And second condition, this f of x is always greater than or equal to 0. Right. So, first condition is that f of x should be equal to 1 when integrated between minus infinity and infinity, and f of x should be greater than or equal to 0. And one more is that probability of a less than x less than b or included also is the same in continuous will be equal to integral from a to b f of x dx. That means we are finding the area under limits a and b. So, a function f of x is said to be a probability density function which satisfies the first and second condition, that is f of x should be greater than 0 and integral of f of x between limits minus infinity and infinity should be equal to 1. Now, we will see what is a cumulative distribution function. So, for a continuous random variable x with probability density function f of x, the cumulative distribution function is denoted by capital F of x and is given by probability of x less than or equal to x, which is given as integral of f of x dx between the limits minus infinity to x, where this x takes values from minus infinity to infinity. Right. Now, cumulative distribution function is given by integral. If I have to find out the probability density function f of x from here, then we have f of x equal to as d by dx of, we have to differentiate cumulative function. So, f of x will be equal to d by dx of f of x. Right. And we will see what is mean and variance here. So, mean Now, we will see what are the measures of central tendency for a continuous random variable. Mean mu is given by integral of x into f of x dx between limits minus infinity and infinity, and variance sigma square is given by integral of, that is already we know that it is given by expectation of x square minus mu square, which can be written as integral x square into f of x dx between limits minus infinity to infinity minus mu square, where mu is mean. So, mean is given by integral of x into f of x between minus infinity and infinity, and sigma square is given by integral of x square f of x between minus infinity to infinity minus mu square. Now, we look into some examples. So in this example, he has given the diameter of an electric cable is assumed to be a continuous random variable with probability density function. He has given f of x as 6x into 1 minus x between interval 0 less than or equal to x less than or equal to 1. So what you have to find? He is asking us to find, check that above is a probability density function, and also we have to find the expression for cumulative distribution function. So first we'll check whether it is a probability density function or not. So as we have discussed, if we can show that integral of f of x dx between limits minus infinity to infinity is equal to 1, then it is known as a probability density function. So if I take integral f of x between minus infinity to infinity, so this is equal to, here the function is defined between 0 and 1. So in remaining it will be 0. That means between minus infinity to 0, f of x dx plus 0 to 1 f of x dx plus 1 to infinity f of x dx. So the given interval I am taking into 3 parts: minus infinity to 0, 0 to 1 and 1 to infinity. And if of all this, in between 0 and 1 the function is defined, remaining values will be 0. So this is equal to 0 plus, I will write f of x, so 6 I will write it outside, 0 to 1 x into 1 minus x dx plus 0. Now we'll integrate this function. So this is equal to 6 integral from 0 to 1. I'll take this inside the brackets, x minus x square dx. Now integrating, this is equal to 6 into x square by 2 minus x cube by 3 between limits 0 and 1. Now we'll substitute the limits here. So this is equal to 6 into 1 by 2 minus 1 by 3, and substituting the lower limit, the value is 0. So this is minus 0, and substituting 6 into, here when I take, we'll have the value as 3 minus 2 by 6, that is 6 into 1 by 6, which is equal to 1. So we can say that the given function is density function, since the integral of f of x between limits minus infinity and infinity is equal to 1. Hence f of x is a probability density function, that is PDF. Also we have to find cumulative distribution function for this function. So we'll define cumulative distribution function. So capital F of x is equal to integral from minus infinity to upper limit is x, f of x dx. So this is equal to, here the function is defined in the interval 0 and 1. So we'll divide this interval from minus infinity to 0, f of x dx plus 0 to upper limit will be x to f of x dx. And we know that in the interval minus infinity and 0 the value is 0. So this is equal to 0 plus integral from 0 to x, f of x is 6 into x minus x square dx. Now integrating, we have 6 x square by 2 minus x cube by 3 between limits 0 and x. Now substituting the limits, we have this as 6 into x square by 2, upper limit is x, so x square by 2 minus x cube by 3, whereas the lower limit is 0. So this function is equal to 6 of 3x square minus 2x cube by 6. So, we got f of x as, now I will write down f of x. So, f of x is equal to, in between interval 0 and 1, the function is given as 3x square minus 2x cube between the interval 0 and 1. Whereas in the interval from 1 to infinity, the value will be 1. Since we are finding the cumulative distribution, the value will be 1, and in the interval from minus infinity to 0, the value is 0. So, the cumulative distribution is given by 3x square minus 2x cube in the interval 0 and 1. Thank you.